Hello students, this is Broxgag. So I'm going to make a video here that's kind of a companion video with the position displacement problem that we just worked. And so before we did an analytical solution method where we're trying to figure out how much we need to raise the cylinder in order to have point D over here go from 17.25 feet above the ground all the way up to 22 feet above the ground. And so if you remember, we basically picked out a few triangles that we can make amongst the geometry, related some links and angles together in order to come up with an extension of 11.23 inches needed by the cylinder. And so this is a fine way to do it. It's analytical. It doesn't require much in the way of fancy software or anything. It's really just you and a piece of paper and a pencil and a calculator in order to knock this out. But what if you do want to do it graphically? Well, that's what this video is going to be about. And so I'm going to make this video using Autocad. You could also use SolidWorks. I might even create another one showing the exact same problem in SolidWorks. But for this one, I'll just choose Autocad. If you don't have Autocad, really any tool that you can draw lines and draw circles and be able to control the line so you can control the angle that you draw and the length of it and so forth and be able to measure geometry off of should work for you. And so a lot of CAD packages have that base functionality built into it. One of the reasons I like AutoCAD is because it's fairly simple, and also I like the layer aspect of it. Here in this case we need to draw the mechanism in its beginning state when the point D is 17.25 feet above the ground, and also its end state when it is 22 feet above the ground. And so we can use the layer functionality inside of AutoCAD to keep all that together. And so what you're seeing now is I've just hopped into a drawing file in AutoCAD. And one thing I'll do is I'll go ahead and change my units. I just typed in units there, right in the command line area. And we'll change the insertion scale to feet and hit OK. Really, that's not a terribly important thing for us at this point, just because all our units are going to be all our numbers will be the same unit, and we can just read off the value from AutoCAD and know in our head that, hey, that's a value in feet instead of inches. Next thing I'm going to do is I'm going to create some layers. And so layers, I can either come up here and click on the layer property manager, or you can see from the tooltip, if I just type in layer and hit enter, it brings up the same dialog box. And so if you're new to AutoCAD, basically layers allow you to organize your work, and so you can have, say, a house floor plan, and all the walls may be on a layer, all the plumbing may be on a layer, all the electrical may be on a layer, all the HVAC heating, ductwork may be on a different layer, and so forth. That way, when you're working on something, you can then hide and show other items as needed. And so for us in this example, I'm going to create an initial layer. By clicking the new layer icon here, I'll create a final layer. So this is the initial position, the final position. Let's also create a dim layer here that we can put dimensions on. There's lots of layer properties. That's what all these icons here to the right are at. And really the only thing I'm going to be worried about is color, so I can differentiate between these. So let's say my initial is yellow, my final I'll make green, and my dimensions will make a very light gray. And so that gets us going. One other thing, the green check mark here indicates the active layer. And so the first thing I'm going to do is I'm going to draw things on the initial layer. Also, right up here, this drop down shows you the current or active layer as well. So we're setting it to initial. And so now back to my OneNote sketch here. We're trying to lay out the mechanism just the way it is in the picture here, where y sub d is roughly 17.25 feet above the ground. Really, all the motion, as you can see, that we're interested in happens at around point A, B, C, and D there. And so one thing we could do is just draw in points A, B, C, D, and we could also have a ground reference if we would like. And so let's go ahead with that idea. And so with that, I'm just going to type in L and hit enter. That gets the line tool going. And I'm going to turn this guy right here on ortho so I can draw a nice vertical line. Doesn't really matter the length at this point. This is just going to be my ground, if you will, that kind of zero-based datum. And now I know point A is going to be 4.75 units above the ground and 3.75 units, or excuse me, 3.75 units above the ground and 4.75 from where that contact patch is with the tire. So 4.75 and 3.75. Here One thing I could do is just draw a line a few different ways. Turn off ortho. I'll draw a line. I'll hit at for relative and just enter in that relative ordered pair 4.75 comma 3.75. And this is just a very crude way in order to reference this point here. And so at the end of this point, we'll call that point A. One thing I'll do is I'll use donuts in order to locate these fixed pin connections. So here I'll just create a donut right there. Also, you are able to create text, and so just for the video to make sure everything's staying in check here, we'll create this letter and move it so we label point A there. Using the same idea, we could locate point B. You can see point B is going to be 8.25 feet from our reference point and 5.25 feet up. And so again, we could do a line and draw it here. There we go. And we would type in 8.25 comma, oh, I forgot the at tool. Sorry about that. Hit the at, because we want to go relative, 8.25 comma 5.25, excuse me. 5.25. There we go. And so that should be the location of point D. So I'll just copy now by typing copy the first donut over, and I'll have it lock on the location there. Now I don't need this line anymore. I can also just hit copy again, copy my A, move it over here, and change it to B there just by editing the characters inside of the multi-line text object. Alright, so A and B are put in place there. One thing we could check very quickly and just go to the linear dimension tool and put some dimensions. There's 4.75 by 3.75 there, just looking good, and 8.25 by 5.25 there. And so at this point, all we've done is really referenced these 2 points in space and have that figured out. So some other stuff I have is I know I need to reference point C. I need to figure out where that's going to be at in space. And point C, I can use its relationship between point A and point B in order to locate where point C is at in space. From the wording here, I know that point C is going to be 5.21 feet from point A, because it's just the length of the cylinder. And so one way I can do that graphically is just draw a circle. I'm in AutoCAD, just hit C enter for center point circle. I can use the center point as the center of point or donut A there, and then I'm waiting for it to specify a radius, and so 5.21 feet is the radius. So now I've drawn a circle with 5.21 feet being the radius, and it's centered exactly at point A there. And so what this tells me is that point C is going to lie somewhere on this circle. I just don't know where at this point. And so that's where we can use the information about point B and its distance between point C in order to help us define that, because we know the distance between B and C will always be 6.5 feet. And so the same idea, we'll draw a circle. It'll be centered at point B. It'll have a distance of 6.5 feet. And so enter that for the radius. And zoom out, we've got 2 intersection points you can see. One being up here in the kind of the top left, the other being down here in the bottom right. And so these would be the 2 solutions of where point C could lie, given those 2 criteria. Here, you just use inspection really. It's obviously going to be at the top point here. And so what we would do is draw in lines, say here, here, and here. And we can now remove these circles for the time being. And we know that this is the cylinder, and this is the 6.5 feet, the distance between A and C there. And so I'll just copy this text object here, and I'll just put L cylinder in order to make sure everybody's still following along. And so that's the cylinder length. Other thing I have here is I need to locate point D. And so point D is always going to be 24 feet from point B. And so same idea, I can draw a circle centered at point B, having a radius of 24 feet. So you can see it's a much larger circle there. And now what I need to do is I need to basically grow this line segment, that line segment right here, until it contacts the circle over here. So what I can do is I can just use extend, and so I can just type in the first part of extend there. You can see it picking up the tool command inside of AutoCAD. I'll just accept that. I'll select the boundary that I want to extend the line to, hit spacebar to accept that entry, and then I'll select the line segment. And notice what we're doing here is we're extending the line associated with the boom, or the arm if you will, all the way up to point D there. So now I can delete this off. And so really this is the initial position of the mechanism. If I measure here, I should get close to 17.25 feet. Here I am a little bit off. You can see 17.27. The reason that is because I'm sure I rounded this 5.21 value in order to come up with 5.21 feet here for the problem statement. So that doesn't give me too much concern. And so this is the initial configuration of the mechanism. So we'll now turn the layer over to the final configuration or position of the mechanism and work toward that. And so really it's the same process. Here our known input is that we need the point D here to go to 22 feet above the ground surface here. And so that's going to be somewhere up here. Obviously this point's going to go up. We need some reference here to determine where 22 feet is going to be. And so what I can do is just offset this ground line upward, in this case, by 22 feet in order to have that reference. And so I've offset it here. Notice it's still yellow. Really I want that to be green, so I'm going to select it, then I'll just use the combo box here to flip it to the final layer. And so this is how high we're needing the point D to move. How we're able to position point D? Well, we know it's always going to be 24 units again from point B, and so I can redraw this circle here, centered at point B again, radius of 24, and I'll hit enter. And so notice we've got an intersection point over here. Really I'm interested in the intersection point over here to the left. Again, it's a method where we're going to have to extend, so I'll type in extend, select the boundary, hit spacebar, select the length that or the unit, not the unit, the object there that I want to grow, and have it extend over. And so this point right here represents point D after it moves this arc length up to 22 feet. And so here I'll just get a line tool drawn in here in order to represent that link BCD there. And so at this point I can remove both of those pieces for construction. So next thing we need to do is locate point C along this line here. And so point C again we know is always going to be 6.5 feet from B. And so we'll draw the center point circle, center of the circle here, radius being the 6.5 feet. And we have this intersection right here that we'd be interested in, because that intersection here is going to allow us to draw this line here between the intersection and point A. So really what you've got, if you want to label it, this would be, I'll get that selected, I'll right click, go edit. This is our C primed, if you will, or our second position of C, and this is the first position of C there, if that helps to visualize what we've done at this point. So at this point, we're most of the way there. We've got one length here, one length here. These two lines represent the cylinder at these two different states. Now we need to measure, and so I'll switch to the dim layer here. We want a line dimension in this case because we want to measure along the length of the line, not just a horizontal or vertical component. And so I'll just draw that dimension in there, 6.146 feet. Just to check, there's my 5.21 feet, and really this difference is what we're after. And so I'm just going to go QC to get the Autocad calculator here up. And so what I want to do is really take the difference, 6.146 minus 5.21. That would give me the extension of the cylinder in feet. And so I'll multiply it by 12 in order to convert to inches. If I hit enter, hopefully you can read that on the screen. There in blue is 11.23 inches being the extension needed by the cylinder. And so one thing we can do is come right back into our analytical calculations make a quick comparison. 11.23 inches with the result we saw there, and again we're seeing 11.23 inches with our graphical techniques here. And so that's great that they match up. That's one good thing about having two different methods to solve this problem. You could work one out and then work a second one out, largely independent of the first one, and it allows you to check your work here. Because obviously in the analytical side, it's very easy to say enter in a wrong parameter. You meant to grab one length, you grabbed another length, or even when you're entering things in your calculator, it's easy to slip up there as well. And so this serves as a great check for that analytical solution we did in the previous video. And so I think that wraps this video up. Thank you for watching the video, and hopefully this video helps you to use AutoCAD to lay out your mechanisms and perform position and displacement analysis for your kinematic studies.